Before you can start learning how to hack web applications or websites, you need to understand how websites work and how we as users talk to these websites. If you want to master bug bounties, penetration testing, or web security, you have to know and learn how web applications work. In this video, we will decode the language of the web, interactions between your browser and servers behind every website. We will dissect this one HTTP request at a time. Think of the internet as a giant post office. Your browser sends the letters. Okay, in this video, we will read the envelope, decode the message, and see how servers which house the websites reply to your messages. Let's get to it. Okay, so first, let's get to learn the different components of a web application, aka the website that you see on the internet. Now, the first thing or the first component which we see or which we interact with using a web browser is called the front end. The front end is basically the component of an application or a website that we interact with using the web browser. When we click the buttons, when we browse through the pages of a website, this is called the front end. Okay, the thing that is that's presented to you when you first open a website. Now, the front end is composed of three components or three programming languages compose the front end. First, we have the HTML. Next, we have the CSS. And three, we have the JavaScript. These are the three basic programming languages that compose the front end. Okay, so regarding the HTML, basically HTML is a set of instructions that represents the DNA of the web page. It tells the browser how to display the website, and of course, it contains the instructions how and what to display for the user. Next, we have the CSS. Probably you have heard of CSS. Basically, CSS stands for Cascading Style Sheets, and it contains instructions on certain aspects of the web page, such as the colors, the type of text, the layouts, and basically it complements the HTML. Without CSS, HTML, the website will look very plain. Okay, no one will be happy to look at the website without CSS, without colors or style. It's the style. And in CSS, or if you are auditing a website or looking into the website files, you will see a very prominent file named style.css. Basically, if you want to configure or to play with your website looks, you will go to this file, and basically that's where you set the colors, the text size, etc. Okay, now the JavaScript. The JavaScript is like the dynamic aspect of the web page. So basically, in HTML and CSS, we set the page, the text, the styling, but since we need interaction with the page, interactive columns, so interactive components, such as maybe the buttons, the forms, these are called interactive components. These can be set with JavaScript. Okay, it enables actually more complex activity in the web browser. So we saw that HTML can be considered a simple set of instructions on what to display. JavaScript is more advanced instructions, more advanced version of HTML. It allows you to interact with the web page in a more complex manner, such as forms, buttons, pop-ups. These are all called or part of JavaScript. It's basically the brain of an advanced organism. Okay, so that's the front end. Now let's talk about the backend. The backend is the component of our application that we users do not see or directly interact with. It's the part that, or it's the space reserved for those who made the web application or created the website. We call these guys the developers. So basically, developers work with the backend. Users work with the front end. And I know there are developers that also work on front end. But basically, we as users, we interact with the front end component of the web application. Developers interact or basically control the backend and the front end together. Of course, when we are talking about development or designing the site. Okay, now, so what lies in the backend of a web application? We see the server logic and we see the data processing. Most importantly, the database is considered as the most important component of the backend. Without a database, we cannot store data that will be displayed on the website. For example, WordPress a popular content management system. WordPress cannot exist without a database connected to the site because you will not be able to store users, you will not be able to store posts and pages. So database stores data. It's responsible for data storage and data retrieval, and it is an important component or a main component of the backend. Okay. Another component of the backend is the web application firewall. If you decide to protect your website or web application from malicious attacks, you would install a web application firewall. The application firewall is installed on the back end. It's responsible for request filtering and protection. Request filtering meaning all the requests that come from the user, okay, are they are processed by the backend, but they're also filtered using the application firewall to make sure they do not contain any malicious input or malicious crafted strings or other form of data. And protection, and therefore it's responsible for protection. So these are the components of a web application or a website. Okay, now let's get to the questions of the tasks. So in task 2, application overview, we have 3 questions. Which component on a computer is responsible for hosting and delivering content for web applications? It is the web server or the web application. Which tool is used to access and interact with web applications? It is the web browser. The web browser is used to interact with the web application or the web server. Basically, the user interacts with the web, the front end part of the web application. Which component acts as a protective layer, filtering incoming traffic and to block malicious attacks and ensuring the security of the application? It is the application firewall, as we stated earlier. Now in task 3, we have uniform resource locator or the URL. We're going to talk about the URL. Now that we have understood the components of a website or an application, now let's talk about the URL. So I'm going to use the illustration here put in the TryHackMe's room, and we're going to dissect the components of the shown URL. So as you can see, first we have the scheme, or we call it the protocol in blue. So in this case, it is HTTP. It can be HTTP or HTTPS. HTTPS is the secure version of HTTP, which is the protocol used for web communications. Next, we have the next component where the user and password are shown. Now, rarely these days you see username and password shown in the URL. So basically, I'm going to ignore this, but in some rare cases, you will see user and password in a URL because they might be required to log into a certain administration panel or website, but it's rarely used. At tryhackme.com. Now, this part in red is the host or the domain, which is the main component that lets you know where you are or what website you are browsing, the name of the website. In this case, it is tryhackme.com. It's worth mentioning that attackers these days use a tactic called typo squatting. Typo squatting is a tactic that where an attacker can or actually manipulates the name of the domain. For example, if they want to target TryHackMe users, they would register a domain that is a misspelled version of tryhackme.com. It could be tryhackm without the e.com. So users would think that this is the real TryHackMe. However, this is the misspelled version of tryhackme.com. Usually it's used throughout phishing campaigns to trick the users into clicking on links or downloading certain attachments. Okay, the port here is 80. And again, ports are not used in URLs. They are implicitly used, of course, but they are not shown, as you can see here. I'm browsing through TryHackMe. The URL states tryhackme.com, but there is no port. However, in manual implementations of web servers, such as those used in demo scenarios or in cases where you are developing a website and the website is not released yet, you might see the port in the URL, or if the port is not 80. If the port is customized depending on the web server, and if the value doesn't equal to 80, it could be 8080 or maybe 4545. So in that case, you will see the port in the URL. And if the port is specified in the URL, it most likely it comes after the domain name. And it is separated from the domain name using a column. As you can see, it is in black. Okay, next we have after the slash. So there is a slash that comes after the domain name, right? And there is, you see the page name. After the slash, we see the page name, or what we call it the path. The path specifies what resource you are accessing on the site. So the subsite is composed of web pages. You can access the web pages on the site And you can see the name of the page shown, or the path to the page shown right after the first slash that separates the resource from the domain name. And next we have, in that case, we have the ID, or what's called as the query string. Now, in the URL above here, as you can see, where I'm hovering over, there is no ID, or there is no query string. It's because I'm not using certain functionalities that require the use of query string. When you see query string here, such as ID or product ID or any other name, this is called the parameter. This means that the user is using a search feature or using a certain form on the site. And the query string is used to identify the search string or the form that the user is using. Most prominently, you will see the query strings when you perform a search throughout the site or when you submit a form. And then we have task 3. So this fragment comes after the pound character. This is called the fragment. And it is used to allow you to jump between sections on the site. For example, if I click on Save Room, okay, now I know this is not a real example, but the jump, if this was a jump, if this was a fragment, if I click on Save Room and it was a fragment, it would direct me, or it would allow me to jump to the part of the page that is considered as a section of the save room. Okay, we call this the fragment. Most prominently, it's used in menus. So in a menu, if you have a website that's only a single page and it has a menu, the menu is linked to specific sections on the site. For example, if the task 3 here was linked in the menu, when you click on task 3 in the menu, it would jump directly to task 3 without directing you or sending you into another page. And that's called the use of fragments. Okay, so that's task 3, the component of a URL. And here we answer the questions: which protocol provides encrypted communication to ensure secure transmission between a web server and a web browser and a web server? It's the HTTPS. What term describes the practice of registering domain names that are misspelled variations of a popular website to exploit user errors and potentially engage in fraudulent activities? It is the type of squatting, as we explained. What part of a URL is used to pass additional information, such as search terms or foreign inputs, to the web server? It is the query string. Now let's talk about the HTTP requests and responses. So basically, these are called HTTP messages. When you refresh a page or when you access a web page, you are actually sending an HTTP request. That's an example of HTTP request. Now, this request is generated because I try to access TryHackMe. So the request here is composed of 2 parts. First is the HTTP header. And after the header, if there is any data that I passed to the website, such as username, password, search query, or a form, it will be shown here. Since I only accessed tryhackme.com without passing any additional data, such as the ones I mentioned, as you can see, there is no HTTP body. So this is the HTTP header. And then we have, as you can see, at line 12, there is a space or empty line. This empty line is purposeful. It exists for a reason. It separates the HTTP header from the HTTP body to make sure the communication between you and the server goes smoothly. Now, these parts compose what's called as the HTTP header. As you can see, HTTP header is consisted of key value pairs. For example, we can see the HTTP request type, we can see the host we are accessing, the user agent, the content type, the language, and in some other cases, such as the one here, let me show you which one. In some other cases, it contains information such as the cookies that are set. If you have a previous session logged on the site, it will show the cookie here. If you have accessed the site before, you'll have been assigned a cookie. So the next time you access the site, the cookie will be shown in the HTTP request. All right, now that we have talked about the request, let's now talk about the response. So once you send the request to the website will respond by displaying its contents. Okay, so now let's have a look at the response. So on the right, we can see a sample response. Again, it follows the same formula. Basically, you have the HTTP response headers, and then at line 12, we have an empty line that separates the HTTP header from the HTTP body. So we have first the headers. We can see the response code. 200 means that the web page exists and valid. also have the date, the content type, the session cookie, if the session cookie is assigned again to the user. And after that, after the HTTP headers, we have an empty line, and then we have the body. The body represents the actual response from the web server. In this case, it is the web page or the HTML code of the web page. Okay, now let's get to the questions. Which HTTP message is returned by the web server after processing a client's request? It is the response. What follows the headers in an HTTP message? What follows the headers is the empty line and then the HTTP body. So the empty line comes before the HTTP body. Okay, now let's talk about HTTP methods. These methods can be seen while sending an HTTP request, such as the ones we saw here. So in this request, we are sending at the first line or the status line, we are sending a GET request here. A GET request is an HTTP method that is shown in the HTTP request or as part of HTTP request headers. It is used to retrieve data from the web server. There are other forms, other type of requests, such as post. All of them will be discussed now. So basically, we have first GET. We discussed GET. Let's have to zoom in first. Okay. So we said that GET is used to retrieve data from the web server. Okay, now GET is off the list. Next, we have a POST request. Usually, POST request is used to send data to the server, such as forms, when you fill out a form, when you upload data, or when you send your username and password. These are all of these operations are done through a POST request. Okay, next we have a PUT request. When you see PUT request in an HTTP request header, this means that the user is trying to replace or update something on the server. So it's used to update or replace data. Next, we have delete. So in delete, the user attempts to remove something from the server. Both delete and put should only be used by authorized users, because if an attacker or unauthorized user can use or can send put or delete request with successful responses from the web server, it means that that user can modify or delete data from your server. Okay, now we have patch. So patch, it is used to update part of a resource. Basically, if you want to make small changes without replacing the whole thing. Next, we have head. So head request is used to, it's similar to a GET request, but only send or use for headers. It only retrieves the headers, not the full content. Next, we have options. So basically, in options, it tells you what are the available methods and what are the available HTTP methods that the web server can accept. Sometimes the web server can only accept GET and POST. It doesn't accept delete or patch. All of these options can be discovered, all of these settings can be discovered by using the options method. Next, we have trace. So in trace, it shows which methods are allowed, often also used for debugging. And lastly, we have connect. So connect is also used for creating a secure connection. So basically used to establish secure connections, essential for encrypted communication, similar to HTTPS. So HTTPS is a protocol. It's not a request header or a request method. However, it's similar in purpose. Both are used to create a secure connections. So these are the HTTP methods that you might use while sending a HTTP request. Now let's get back to a sample HTTP request. So for example, this one, as you can see, the first line, we discussed that it contains the HTTP method, the web page, the resource being accessed, the query strings, and as you can see, we have HTTP/2. This specifies the HTTP version. And we have a lot of HTTP versions. Let's go through these versions. The first HTTP version that was introduced, it was introduced in 1991. And it happens to be HTTP 0.9. It is the first version that supports GET requests. And then they moved on in 1996. They moved on to HTTP 1.0. It's basically where they added headers and support for different content types. And of course, they added support for caching. And then they decided to add another improvement. In 1997, they moved on to HTTP 1.1. It's where they introduced the persistent connections, and chunked transfer encoding, allowing for better caching and increased performance. Okay, they didn't stop here. In 2015, they added an update where they moved on to HTTP 2/2. In HTTP 2, they introduced more features such as multiplexing, compression, and they prioritized faster performance for web browsing to increase the web browsing experience quality for the users. They didn't stop here. In 2022, they added the most recent HTTP version, which is HTTP/3. In this version, they basically use a new protocol, UIC, for quicker and more secure connections. That's the timeline of the HTTP protocol versions. Now let's talk about the content type. Oftentimes you see content type as part of an HTTP request header. So basically, this specifies the type of content you are sending to the server. Basically here, the content type is, for example, as specified in the room, is form URL encoded. That part or that content type is basically used to send data to the server, such as in the case of sending forms or maybe login forms as well. Submission forms and login forms. Sometimes you are sending contact form, sometimes you're sending a login form. So basically, this is called, or the content type for this transaction is called, named as application form URL encoded. And basically, you can see in the request body, there's an empty line, and then we have the data that are sent in the request body. In this case here, we have name, we have age, and contact. This is an example of data that is submitted through a contact form. You see the data contains the key and the value. They are key value pairs, and an equal sign separates between the key and the value. And of course, between the key value pairs, there is an ampersand that separates all of them. This is called form URL encoded. Another type of content you see in HTTP requests, you see here it is multi-part form data. And basically, it is used mainly when you upload something to a web server. Form upload. When you upload data, most of the time it comes, the content type is multi-part form data. And you can see here that there is a boundary string separating the data sent to the web server. The first boundary string, we see the username, and then the data that was uploaded by the user is also seen here, and the content type of the data that was uploaded. Another type of content sent in a request header is the JSON, which basically stands for Java Object Notation. JSON is another representation of data, such as we see here. As we saw previously, the foreign data can also be represented using JSON. And lastly, also we have another representation of data we can see in content type if the data was sent is XML. All right, now I want to answer the questions. So basically we start with task 4. We did task 4, now task 5. Which HTTP protocol version became widely adopted and remains the most commonly used version for web communication, known for introducing features like persistent connections and chunked transfer encoding? We discussed these, and you can also review them here in the task. It is 1.1, which request method describes the communication options for the target resource, allowing clients to determine which methods are supported by the web server. It is the options. And lastly, we have in an HTTP request, which component specifies the specific resource or endpoint on the web server that the client is requesting, typically appearing after the domain name in the URL. It is the URL path, which specifies the page or the resource you are accessing. Okay, task 6. Which HTTP request header specifies the domain name of the web server to which the request is being sent? It is the host. The host can be seen here. So in the example here, the host is safebrowsing.googleapis.com. It means I'm trying to access this domain. What is the default content type for form submissions in an HTTP request where the data is encoded as key value pairs in a query string format? We also just discussed this. It's the form URL encoded, and which part of an HTTP request contains additional information like host, user agent, and content type, guiding how the web server should process the request. These parts or this information are mentioned in the request headers or HTTP request headers. All right, now let's talk about the response sent by the server. There is something called the status code. So when you send a request to the web server, The server responds by displaying the page or by telling you that the resource you are accessing might either be removed or uh, has been redirected to another page. So how do you know that this is the case? Of course, you're going to observe the web page, response to the web page, but while troubleshooting, you can find out the server response at the very first line, which is called the status line. Here you can see, again, the version of the HTTP and the status code. The status code indicates the status of the response. 200 means that the server accepts the request and displays a proper response to your request. There are other codes as well, and they indicate different statuses. Let's talk about these HTTP response codes. Okay, so these are the most common ones. First, we have 100. 100 means that the server is waiting for the next batch of your request. If you're sending a first batch of requests and then you want to send another request, you will receive 100 continue, meaning that the server has got the first part of the request and is ready for the rest of the remaining of your requests. Next, we have 200, most common seen during healthy web communications. It means that the request you sent to the web server was successful, and now the server will send you back the proper response, indicating that it will display the page you're accessing or the resource you're accessing. Next, we have 301, moved permanently. This means that the page you're trying to access has been permanently moved into a new URL, or it could be a new host, another domain. So this means that the page has been removed and redirected, of course. There's a difference. And you will know the difference by understanding the 404. So 404 means the request you are trying to access does not exist on the web server, either because it is removed or because you are accessing a resource that doesn't exist because of a misspelling on your part. Let's discuss the first case. If the resource does not exist on the web server because it has been removed, that's the gist basically, and the difference between 404 and 301. In 301, the resource does not exist on the web server, of course, but that's because it has been moved into a new web page or a new URL. However, the actual contents do exist. In 404, the contents and the URL both do not exist. Unless we have 500 internal server error, which means that there is something wrong on the server end. Either there's a technical problem, or most probably, in my experience, 500 means that there's a problem in the HT access, especially prominent in WordPress installations, or there is a lack of index file. If there is no index on the website you're trying to access, it's going to throw 500 internal server error. Okay, now task 7, questions and answers. What part of an HTTP response provides the version, status code, and a brief explanation of the response outcome? It is the status line we just discussed. Which category of HTTP response codes indicates that the web server encountered an internal issue or is unable to fulfill the client's request? It is the server error response, or 500. Which status code indicates that the requested resource could not be found on the web server? It is 404. Okay, let's now answer the questions of task 8. Which HTTP response header can reveal information about the web server software and version, potentially exposing it to security risks if not removed? Let's have a look. For example, here we have the server section, indicates the server type. Here we have Cloudflare, which means that the server is hosted in Cloudflare, which is a content delivery network. In other instances, you might see the name and software of the server, Nginx Apache. And that's a security risk because attackers will learn what technology your web server is using. And therefore, this will open chances for more attack exposure. And thus, they will be able to probe for vulnerabilities and try to attack your server. Okay, let's go back. So it is the server section. Which flag should be added to cookies in the set cookie? So these two questions are about cookie security. So the gist here is to add secure and HTTP only flag when you set up your cookies to be assigned to the users. This ensures that the cookies are not transferred in plain text, okay? Only transferred when HTTPS is used, okay? and also protects against XSS attacks. Remember them, HTTP only and the secure flags. This should be set in the cookies. So here we have the cookie, set cookie, and that's an example cookie. Of course, you will not be able to learn from the response whether the HTTP only and the secure flag are set. Sometimes you'll be able to see, sometimes not, depends on the server settings. Last, let's have a look at task 10. I know I skipped task 9, but I will come to it. Let's first go over task 9. So we have a practical task where we simulate sending requests and receiving responses. So I'm going to skip the tour. Okay, so we have the first part here. Let me try to make it this way. Okay, so we specify the type of the request we send, get, post, put, delete. We discussed all of these. And here we specify the link or the host we want to send the request to. And we have the settings. If you want to adjust the query parameters or the query strings, we put the name of the query string and its value. And when we are ready, we click on go, and we can see the request header. So as is here, the request header or the HTTP request header contains the following key value pairs. First, we have the request type, the version of the HTTP. In this case, it's specified as 1.1. Next, we have the header agent, and then we have the content length. We go ahead and send a sample GET request. We get to see the response. As you can see, the status code is 200, which means that the resource we have requested on the host named TryHackMe.com exists and is valid. Next, we have the server type. As you can see, the server type or the server field reveals the version and the name of the server. This is dangerous to reveal and not secure. As I said earlier, it will tell the attacker what type of technology you're running and the version of the software. The date, the content type here, it is HTML, and this is the encoding, content length, last modified, and we can see here the actual response in HTML. Okay, let's have a look. Make a GET request to API/users. What is the flag? So we go to the URL and we specify the resource we're accessing, /API/users. Click on go. And you want to find the flag, you're going to have to look at the response. So basically, that's the server response body. Okay, basically, you can see the flag from here. It can be found here. And that's the render or the browser render of the response. Okay, make a post request to /API/user/2 and update the country of Bob from UK to US. What is the flag? Okay, remember that if you are wondering how to do these modifications using a real tool, you can do that using Purpose Suite. As you can see in Purpose Suite, we can modify the request, the headers, we can modify the response, not the response, so the request header and the request body. So basically, that can be called as a simulation to Purpose Suite, a mini simulation. Okay, now let's make a post request. And this time we're making the post request to /API/user/2. It means the second user maybe, and update the country of Bob from UK to US. Okay, so now if we try to make a post request, as you can see, errors because in a post request we need to send data to the server. There's no data specified here in the request, only request headers. Where is the data? It needs to be specified in the request body. So we click on the settings and we add the query strings. First, we have the query string of country. So the country has to be US and update the country of Bob. Basically, I'm going to assume that the query string is a user and the value is Bob. Let's have a look. As you can see now, the country equals the US and user equal to Bob. This is the request data. The HTTP request body, the data we are sending. Now, if you send, let's see. Okay, let's make a GET request again to users. Okay, now one more time to /API/user, and this time it is post. Go. You see, title TryHackMe, but the page cannot be found. Let's go back a little bit. Here, /user/2 post. In the list of the values, I'm going to proceed only with the country And we see the user has successfully been updated, but we do not see any flag. Let's see here. So probably the country has to be lowercase. I will delete this and we'll say country equals to US. And now we see the flag. Lastly, make a delete request to /API/user/1 to delete the user. What is the flag? Looks simple, right? So we're gonna just change the user ID from 2 to 1, specify delete, click on go, and you receive the last flag. Okay. Let's go back to the room. I just move on to the next room without knowing. Okay, now I promise you to go over task 9. So in task 9, we learn the different types of security headers that are used to protect your web server from different types of web attacks. And here we have securityheader.io, which allows you to scan your site and learn the request headers. Okay, now if we take an example such as TryHackMe and enter the site name, click on scan, we see the issues with this site and the type of security headers used on the site. Here we have the list of the headers. For example, strict transport policy security header does not exist. Content security policy does not exist. All of these are security headers that can be set up on your end to secure your site and secure the transmission of data on your site. And you can see an explanation of every security header and why it matters. If we take another example, such as maybe hack the box, probably it's going to be the same. And a little bit better, we have the permission policy enabled. In this task, we see the 3 main important security headers that are mostly used by websites. First, we have content security policy. The content security policy allows you to specify where to load scripts from. And basically, it protects your site from cross-site scripting. It doesn't allow an attacker to load scripts outside of the website or other trusted domains. You can use an attribute called default source or script source. If you use default source and the value self, it only allows loading JavaScripts from within the site. However, if you use script source, you have to specify what resources or what hosts are allowed to load JavaScripts within your site. Here it's specified as self and other trusted domain, meaning JavaScript can only be loaded from TryHackMe or cdn.tryhackme.com. Other one is strict transport security, which ensures that your website uses HTTPS for its communications. And also it has an attribute called include subdomains to enforce this policy on subdomains as well. Lastly, we have X content type options. This prevents sniffing attacks by preventing a website from guessing the MIME type or the MIME type by using no sniff. And lastly, referral policy prevents, if set correctly, prevents vulnerabilities such as open redirection vulnerability. Now the questions are 3 here. In a content security policy configuration, which property can be set to define where scripts can be loaded from? It is the script source. When configuring the strict transport security header to ensure that all subdomains of a site also use HTTPS, which directive should be included to apply the security policy to both the main domain and its subdomains? It is the include subdomains, as we saw here. The last question is, which HTTP header directive is used to prevent browsers from interpreting files as different MIME type than what is specified by the server, thereby mitigating content type sniffing attacks? It is the no sniff. And that concludes the room. I hope you guys found this helpful.